Jai Shri Gurudev. Good morning to everyone, students. Already we have studied the first method to prepare haloalkanes and haloarenes. The second method is from alkanes. In this method, alkanes, example take CH3 called ethane. Ethane is treated with chlorine. That is halogens in presence of sunlight, that is diffused sunlight. We are writing H nu to get CH3 bond. One of the hydrogen from this CH3 group get combined with one of the chlorine from this chlorine molecule, get HCl and CH3. CH2 bond Cl. One of the hydrogen is replaced by chlorine plus HCl. So this is the mechanism. This whole mechanism we call as free radical mechanism. Hence we are writing here that is free radical mechanism. It means this reaction takes place by free radical. So here you get chloroethane. Similarly, observe one more example. Take CH3 bond CH2 bond CH3. That is called propane. This propane is treated with the chlorine gas in presence of diffused sunlight. In this case, you get two products because this is an unsymmetrical molecule. Observe, actually this is symmetrical molecule. When we broke the molecule at center of this molecule, you get two equal halos. Then center ke bhaga madare ಎರಡು equal parts ಬರುತ್ತೆ. Hence we call symmetrical molecule. Here, if you break anywhere between these two bonds or at these bonds, you get a unsymmetrical molecule. One side CH3, another side CH2 and CH3. If you break here, CH3 and CH2, CH3. Hence, it is an unsymmetrical molecule, so that you get two compounds. And to balance the equation, take two equivalents of propane and two equivalents of chlorine molecule. You get CH3. In first case, one of the hydrogen from the CH3 group is replaced by writing chlorine, and the second step, one of the hydrogen atom replaced by here and putting chlorine. So CH3 CH2 bond CH2. So replace here, you get Cl plus. So one hydrogen and one chlorine becomes HCl. And the second product, observe, we are writing two equivalents. Therefore, next one, CH3 bond CH3. So here, one of the hydrogen is replaced by writing chlorine, Cl. And you get two equivalents of HCl plus 2HCl. This is the byproduct. So here, among these two, this one is more stable than this one. Hence, this is major compound and this is minor compound. Why it is major compound? Because you get secondary free radical here before adding chlorine or substituting chlorine. Here you get primary free radical. The stability of free radical is primary carbon free radical is less stable. This is primary carbon free radical. This dot indicates free radical. And this is secondary carbon free radical is less stable than tertiary free radical. It means tertiary carbon free radical is more stable than secondary and primary. Okay, this is the decreasing order of stability. Tertiary is more stable. So here you get secondary, hence you get this has major product. So its name is chloro. 1, 2, 3 carbon atoms, that is propane or 1 chloropropane. This is 1, 2, 3 2 chloropropane. Similarly, the number of carbon atoms increases the products also increases, that is isomers also increases. This is the method of preparation of alkyl halides from alkanes. The second one is from alkenes. The third method is from alkenes. Under that, this is preparation of monohaloalkanes. Under that, preparation of monohaloalkanes. So here, to prepare monohaloalkanes from alkenes, take alkenes, generally CH2 double bond CH2, that is called ethene. This ethene is treated with the hydrogen chloride HCl, hydrogen chloride. This addition of hydrogen chloride between double bond is follows Markovnikov's rule. Markovnikov's rule. So you already studied in your lower classes. It means in first PU, the addition of hydrogen from HCl should be added to the carbon that contains number of hydrogens is more. Similarly, the negative charge, that is chlorine atom, get attached to the carbon that contains least number of hydrogens, that is called Markovnikov's rule. So here both are same, means same number of hydrogen atoms is contained, hence the Markovnikov's rule doesn't apply. Therefore, H is added to the one carbon and chlorine is added to the one more carbon. You get CH3. If hydrogen gets attached to this carbon and chlorine to this carbon, you get CH2 bond Cl. Okay, its name is what? Chloroethane. Chloroethane. Similarly, now observe one more example. If you take unsymmetrical, this is example 1. If you take second example, take propene, CH3, CH double bond CH2. What is name? Propene. 1, 2, 3 carbon atoms. 1, 2, 3. First carbon containing double bond, and second write 1 propene on propene, which is reacts with hydrogen chloride HCl. You get so here the negative port is Cl minus. It will attach to the carbon which containing less number of hydrogen between carbon-carbon double bond. Okay, therefore Cl will attach to this carbon and H will attach to the CH2 carbon. What you get? Write CH3 bond CH. One of the chlorine get attached to this carbon and write Cl bond CH3 because hydrogen goes to this carbon. What you get finally? This product plus no byproducts. What its name? Give number 1, 2, 3. So 2-chloropropene. That is 2-chloropropene. You should apply Markovnikov's rule in such cases. Means when we are taking unsymmetrical molecule. Similarly, now take one more example. That is styrene. This is benzene bond CH2 double bond CH2. So this is same as like ethene. Observe here CH2 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 double bond CH2 CH. One of the hydrogen from ethene is substituted by benzene. Okay, so you get styrene. Its name is styrene, or is also called as ethene benzene. Ethene benzene, which is treated with hydrogen chloride. So just write same. This carbon containing chlorine. But here observe, should apply Markovnikov's rule. Among these two, which one containing least number of hydrogen? This one. So Cl will attach to this carbon and H is attached to the double bonded carbon that should contain maximum number of hydrogen atoms. So what you get? Benzene bond CH bond CH3 is carbon containing chlorine. Okay. Now give number 1, 2. There is 1 chloro, or don't write like that. So 1, 2. This is the longest parent chain. Now give number 1, 2. Among these two, which will get first? This is the phenyl ring, this is chlorine. So chlorine comes first, then phenyl. Therefore 1 chloro, 1 phenyl, 1 phenyl. What is its name? Ethane. Ethane. Okay. So this is the reaction to get alkyl halides from alkenes. Similarly, take homework, one problem, means one reaction, that is fourth one. You should take the homework, that is benzene ring, bond CH2, bond CH, double bond CH2. This is same like this propane, that is 1 phenyl propane. Its name is 1 phenyl propane, which is treated with hydrogen chloride. What you get finally? Here the question mark. You should follow this one. So name the product name. One more example. Take one. Similarly, alkenes, that is take propene CH3 double bond CH2. This is propene. This propane is treated with hydrogen chloride in presence of peroxide. So observe in the last example, honey in second example, we are not written here peroxide. Either you take hydrogen peroxide or metachlorobenzene, that is perbenzoic acid, and any peroxide. The addition of hydrogen chloride between unsymmetrical propene or molecules forms anti-Markovnikov flow, that is also called as Kara-Stool. So here the Cl minus get attached to the carbon that containing high number of hydrogen, and H's get attached to the carbon that containing less number of hydrogen when presence of these peroxides. So example for peroxides, take hydrogen peroxide H2O2 or metachloroperbenzoic acid, that is MCPBA. These are the some examples, best examples of these two. There are so many peroxides, just I am writing two. So now observe what you get product here, CH3, CH, bond CH2. So here H's get attached to the less number of hydrogen atom to the carbon. So here this is less number of hydrogen, so you get the CH2 bond, Cl to the carbon that containing high number of hydrogen, this one. So you get this product. So what its name? Chloropropene. Okay, this is the called anti-Markovnikov's rule or Kara's rule. Similarly, now take one more for homework. Just in place of one of the hydrogen, I write benzene ring, bond CH2, bond CH, double bond CH2. What is name? 1 phenyl, 1 phenyl propene. So it is treated with HCl in presence of hydrogen peroxide, that is called peroxide generally. Predict the product what you get. So actually it is not 1 phenyl propene. Give number 1, 2, 3. Okay, that is 3 phenyl propene. 3 phenyl propene. So write the product name, what you get. This is the method of preparation of monohaloalkanes from alkanes. Similarly, next one, preparation of dihaloalkanes. Then next method, that is preparation of dihaloalkanes. Example, Take first one. So in this case, take alkenes, that is CH2 double bond CH2. So you know it is called as ethene. This ethene is treated with chlorine, Cl2 molecule, in presence of carbon tetrachloride, that is CCl4, is an solvent. What you get, this both the chlorine atoms get added to the across the double bond, means each chlorine to the each carbon, that is CH2 bond CH2, one chlorine for this carbon, one more chlorine for this carbon. So you get this product. Okay, what its name? Dichloroethene. 1,2 dichloroethane. Okay, so similarly take one more example. Take propene. Second example, take propene, that is CH3 bond CH double bond CH2. So it is called propene, which is reacts with chlorine, or either you take bromine also. Not only chlorine, you take bromine, Br2, in presence of CCl4 solvent. So what you get? Similarly, this bromine get added in between these two carbons. The product is CH3 bond CH bond CH2. Here one bromine and here one bromine. So what its name? 1, 2, 3. 1,2 dibromopropane. 1,2 dibromopropane. Okay, so this is the preparation of dihaloalkanes from alkenes. That is the third method. Now next method, fourth one. The fourth method is from haloalkanes by halogen exchange method. So observe here, what is the miracle? We are going to prepare alkyl halides or haloalkanes from haloalkanes only. That is called halogen exchange reaction or halogen exchange method. Now the first one is Frankenstein reaction. Frankenstein reaction. Frankenstein reaction, very important. Definitely they will ask for 2 marks. Frankenstein reaction. In this reaction, alkyl iodide is prepared from or by using alkyl chloride or alkyl bromide. Frankenstein reaction is defined as alkyl bromide or alkyl chloride is treated with sodium iodide in presence of dry acetone. It means moisture free acetone. You get alkyl iodide. Now for example, take alkyl chloride or alkyl bromide, that is CH3Cl. That is alkyl chloride, means methyl chloride. This methyl chloride is treated with sodium iodide, Na, sodium iodide in presence of acetone, that is dry acetone. Means moisture free acetone. Halogen exchange takes place. So observe, chlorine is one halogen and iodine is one more halogen. These two are get replaces, means exchange. Iodine to chlorine base and chlorine becomes iodine base. You get CH3 bond iodine plus this Na and this Cl becomes what? NaCl plus NaCl. So what you get? Methyl iodide. So this is called Frankenstein reaction, very important. Similarly, take one more example. This is first example and second example. Take methyl bromide. Either take chloride or bromide. This methyl bromide is treated with similarly sodium iodide in presence of dry acetone. Dry acetone is used as a solvent. What you get? Hydrogen bromine become what? Sodium bromide, and methyl and iodine become methyl iodide. That is CH3 bond Br plus Na. Sorry, Br, not Br, right? Iodide. Methyl iodide plus NaBr. What you get? Methyl iodide. So remember, in Frankenstein reaction, we should prepare methyl iodides or the iodide compounds. It means alkyl iodide compounds by using either alkyl chlorides or alkyl bromides with sodium iodide and dry acetone. So you may ask, why we can't prepare alkyl halides or alkyl halides such as alkyl chloromethanes or alkyl chlorides or alkyl bromides? Because the sodium iodide is soluble in acetone only. However, this sodium bromide NaBr or sodium chloride, these components cannot be soluble in dry acetone or acetone. So that according to Le-Chatelier's principle, the forward reaction proceed more, hence we get iodide compounds of alkanes, that is called alkyl halides. Okay, this is very important, called Frankenstein reaction. They will ask in exam. You should write these two examples or any one. Then next reaction is Schwarz reaction. So the next reaction is Schwarz reaction. This is also very important. Very important. In this reaction, means in Schwarz reaction, alkyl chlorides or alkyl bromides is treated with metallic reagent such as silver fluorides or mercury fluorides or calcium cobalt fluoride or bismuth fluorides, etc. You get alkyl fluorides. That is, in Schwarz reaction, alkyl chlorides or alkyl bromides, example CH3Cl. This is alkyl chloride, that is methyl chloride. He is treated with mercuric, that is a silver chloride, AgF, treated with a silver fluoride like AgF, or mercury fluoride like Hg2F2, or cobalt fluoride like COF3, or bismuth fluoride like antimony fluoride like SbF3, etc. These are the reagents. Any one among these four we can use. Here we are using silver fluoride, HgF. You get, observe, halogen exchange takes place. Under we are studying halogen exchange reaction. The second one is Schwarz reaction. So chlorine gets replaced by chlorine, that is AgF, and Cl, that is CH3 bond F plus AgCl, silver chloride. So here the my product is methyl fluoride. Okay, so remember, in Schwarz reaction you can prepare fluoride alkanes in the previous example, means in the previous reaction, that is in Frankenstein reaction we can prepare chlorine compound, not chlorine, iodine compounds. You should remember what is the difference between Frankenstein reaction and Schwarz reaction. Definitely any one among these two, definitely they may ask. So similarly, one more example, this is first example. Let's take second example. In place of chlorine, take bromine. That is CH3 bond Br. What is its name? Methyl bromide. Methyl bromide, which will be treated with take any one of the reagent among these three or four. Sorry, any one. Your wish. Take similarly Ag of only. It's very easy to write. So here Ag and Br becomes AgBr, silver bromide and methyl chloride. CH3F plus AgBr. Okay. So if in place of AgF, if they given mercury chloride, then what you can write or how you can write? So how can you write if they given Hg2Br, mercury chloride? So if they given like that. So in such cases, we should take here two equivalents. Okay, if you take two equivalents, then two chlorine atoms becomes Ag2 and Cl2. That is Hg2 and Cl2 here. But you get Hg2 and Cl2. Similarly like that, these two. And in place of CH3Ca, in place of chlorine, write chlorine. That is two equivalents. Like that you have to balance. Okay. Similarly, take homework for this one. I write here one more reagent, that is COF3. I will give COF3. So what you have to write here? COBr, and here take three equivalents and balance the reaction. Finally, you have to write the products what you get here. I put question mark. Okay, take this is homework from Schwarz reaction. Very important. Schwarz reaction and Frankenstein reaction.